Hello everyone, hi. Pause this and have a go, otherwise carry on watching. Let's have a quick read of this question. It goes, Barney suspects that a particular six-sided dice is biased in favour of 2. She plans to throw the dice 35 times and note the number of times it shows a 2. She will then carry out a test at 4% significance level. Find the rejection region for the test. Okay, so first of all, let's just have a quick look at this and first think about what kind of test we're going to run. Looking at it, since there are a fixed number of trials, okay, and we know that in general, if it's a fair dice, the probability of getting a 2 will be, so we know that the probability of getting a 2 will be 1 in 6 if it's fair, and we've been told that the number of times we're going to run this experiment is 35 times. Okay, so if we got these two, we can say that let's just call getting a 2 is x. Okay, so we're going to say x is the event of getting a 2. Okay, so we can say that x will follow a binomial distribution, okay, where we got 35 trials and the success of a trial is 1 out of 6. Now you get a mark for stating that, so we're trying to slowly run through where the marks will be allocated. Now the second thing is to come up with your null hypothesis and your alternative hypothesis. Now for null hypothesis, we want to say that the probability, when it's a fair dice, we're saying probability of getting in this case 2 is going to be 1 out of 6. Okay, and then we'll just quickly read here because we need to know whether it's a one tail or two tail. So Barney suspects that a particular six-sided dice is based in favour. Now that's the keyword here, in favour of a 2. So we're going to say that probability x for getting the 2 is going to be greater than 1/6. Now note we're saying it's greater than 1/6, but she's in favour of getting a 2. Okay, so straight away this makes it a one-tail test. And you'll get 1 mark, 2 marks here, 1 mark for saying that, 1 mark for stating that. One-tail test at 4%, which is 0.04 significance level. Okay, so let's just keep that going. So we're collecting marks. We already got about 3 marks here. Okay, now we're going to try to run the experiment. Now when we're doing this, now it's asking us to find the rejection region. Now again, we're going to use our calculator. And you have a calculator, well, on your calculator you've got a binomial distribution. You've got 2 binomial distributions. Use the one that says CD on it. So CD, which is continuous distribution for binomial. Okay, and use the one where it says list. And if you use that, you'll get something, a table come up where it gives you what I'm going to call the n. And it might show that at x and the probability of getting that many of that. Okay, so how many times was it? Now, as a rule of thumb, what you could do is, well, you should know that 1/6, if it was fair, you would expect 6 of those turning up. Okay, so let's go slightly higher because we do need to make it a bit higher. So I started with 8. You could start with 6, 7, 8, and then just bring down the list down to 6, 8, 9, 10, and I went down to 11. Okay, and then all you do is you put in your calculator the binomial probability of success is 1/6, and number of times you do the experiment 35, the trials, and then press enter, and these are the probabilities you will get out of it. Now these are cumulative probabilities. I'll discuss that in a second, but the probability list is going to give you 0.8837. Just put this in your calculator and double check you're getting these, please, just to confirm you are doing it right. That's going to be 0.9768 and last one 0.9914. Now if you went and did this, now we talked about primitive frequency, I'm going to elaborate here. So what this means is probability of getting like number of trials which were satisfied getting 1/6. Okay, so if that's fair, chances of getting n being less than or equal to 8 would equal that. Okay, so we want to find how many trials we need to exceed. So basically that's what that means. It's created all the, so that will be a summation of getting 0 twos, 1, 2, 3, all the way up to 8 twos. Now if you went through it, if we're looking through here, so we're looking at some of these, like let's just have a look at this one for instance, next one. So if we were looking for a critical region, that probability that getting more than or equal to 10 twos would be the same as 1 minus the probability of getting less than or equal to 9. Okay, so what's the chances of getting 10 or more twos? So if we put that through, we know that probability of getting 9 or less is here. So take away 0.9449, press equals on that one, you'll get 0.551, 511. Okay, so this one we cannot reject. This is because it's greater than 0.4. Don't reject. H null hypothesis. So let's go for the critical region where you get 11 or more. Okay, so you just have to try this out, a bit of trial and error here, seeing whereabouts it is. I reckon this one will be the one. Okay, so just put it through. 1 minus probability of being n is less than or equal to 10. We know that less than or equal to 10 is this one, so 1 minus 0.9768, and that's what you call, go that through the calculator, you'll get 0.0232, which is less than 4%, and at that point you can reject the null hypothesis. Okay, so find the rejection region. So we can now say rejection region is if you get more than or equal to 11 twos. Okay, that's the rejection region. So that's when you reject it. If you went and did this experiment and you got more than 11 or 11 twos, you can then say binary is right and the dice is in favor of 2. Okay, so I would say about 3 marks here, 4 marks, and then about a couple of marks here, and then the odd mark for saying the rejection region where we are. Okay.